There we go.
Okay.
Right. Hello, everyone, and welcome to session 28 of the BGA24. And this session is on GoaT for EBP and for projects in general, isn't it? With Cibele. Take it away.
All right. Thank you. Thank you all for coming. Sorry for the confusion with the time. If everything goes wrong, there is also another one tomorrow. So I will share my screen first so I don't forget this time. Can you see my GoaT?
Yes.
Do you see a chat or do you see a GoaT?
It's a GoaT.
Good. All right. So this talk is going to be another version of the tutorial, but it's focused on the attributes that we usually have for the sequencing projects. So it's going to be focused on not on the general metadata like it was in the previous workshop, but this time the metadata that it pertains to those projects. And I will try to answer some of the frequently asked questions as well that sometimes generate confusion in the community. So the idea is that use this session as a follow-up to the one that we had before. And I actually will make everything available for everybody. Maybe I should, yeah, do you see this? I'll actually get my presentation link to you guys before, so you can follow along as well. Chat. There we go. So here, let me know if you cannot access it, but here is the link to this presentation slides. And I already put inside the slides the links to the YouTube, the live streaming in the BG24 YouTube. We had a preliminary session on the 15th that just explains in general what is GoaT. It was 15 minutes, it was a bit rushed. So I suggest that you start really with the GoaT UI itself. It's a 2-hour long tutorial, but it covers what is GoaT, what type of metadata is there, how to perform the simple and the complex queries, and how to tell apart most of the issues, how to solve most of the issues when you don't know how to tell apart the data. So if it's a summary, if it's a estimate, if the chromosome number is wrong, if the genome size is wrong, usually these are the questions that I'm tackling there. Today, I'm going to just show the UI in a different perspective. So let's say that you are a project manager or just someone that is interested in the progress of sequencing across the board. Then you can use GoaT in that sense. So there will be this 2-hour tutorial today. And then since there was a mix-up with the link, we'll probably have the same one tomorrow, adding a few extra questions if I get any before tomorrow. So before I start, last time I didn't get to introduce everybody. So GoaT is actually an extended group of people. Rich Alice is the main developer. I am the curator for the data and also started as the person that contacts the EBP projects and then give them tutorials and request the lists, import the data. But luckily for me, we have now Fan join the EBP Secretariat as a data management for the EBP. So she's helping me and taking over some of the responsibilities when it comes to data for the EBP network. Max was a bit focused on the plant sequencing world, and then he was using GoaT to do every time using a few of the future features. And he decided to create a command line that would make his life easier. So there is also a command line interface. He's the developer for that. Mark was the person that envisioned the GoaT system. And then we have now 2 people helping with the infrastructure now that we have all of the GoaT systems inside Sanger. welcome Sanger Institute servers. And finally, this is not going to be part of the talk today. We had a contributor for Google Summer of Code project that is implementing natural language to the GoaT query. So people in the future will be able to just hop on a tech chat box and ask how many genomes there are for so and so, and then get the GoaT metadata using natural language. So what is GoaT? For anyone that has anyone in the room right now never heard, never used, and never thought about GoaT before? I just want to see how deep I can go in the introduction of what GoaT is. So if you can say, okay, I never saw GoaT, and put the hands down, how to say this reaction on the chat, then I know that I should be a bit more careful and slow. Okay, at least one person had never seen GoaT before. So don't be scared. That I recommend that you play as much as you can with the system. If you can't get everything today, it's okay, because GoaT really, it is as any other massive platform, it is a data aggregator. So it's a data system. It is not just a single database, it's a non-relational database. It will have many sources from different, many data from different metadata from different sources compiled together into a single system. And then you can query any attribute versus any other within that system. So that makes GoaT very powerful. It has a lot of information, but it's also very tied to its query language that makes sometimes the use a bit more complex. So the idea is that GoaT will be this place where genome metadata, genome relevant metadata, like chromosome number, ploidy, assembly length, assembly level, everything pertaining to assembly, to genome sequencing from plan until done is aggregated there. And then this information is actually whatever is useful for a project that is trying to sequence a species. This information should be in GoaT. So here it is. GoaT is actually built on top of this API that has the Elasticsearch system implemented in a way that is very clever, that the endpoints actually get translated directly to feed the UI and also the command line interface. But most of the people are using the UI nowadays because you can just click on things and see things happen. And so this is the UI for the link for the UI, right, the web. But one thing that I think until this point it wasn't that clear is that the UI of GoaT, it's not really like a user-free platform where you can do anything and select and click nice buttons, because GoaT is a bit tied to its how do I say, its language. There is so much that you can do. There is a lot actually you can do just using query terms on search box, and you can query everything that is behind the scenes. But it's a way that the GoaT can do so much that we needed a way to visualize the power of this API, right? So we create, the UI was created just so you can have an idea of how it would do a query to retrieve a certain type of data, and then quickly visualize how it looks like in case you want to bulk retrieve. So if you look at the GoaT UI and the links that they make, every time that you type something on the search box and you retrieve data, you'll get a link. And that link is unique and is always live. So if you ask in the link how many species are family representatives for the project Darwin Tree of Life, that's what these terms mean. Every time you click on the link, anytime in the future, you'll get the updated version of it. And then if you just change two terms here in the same link, because it has all of the specifications for that query, then you can get it in a computer readable format. So the idea is that we are creating a system that is just not only human readable, right, but it's also computer accessible, and that can be aggregated and interoperable with many other systems. The other thing is that GoaT serves as a window for the kind of a window to the API functionalities, is the ability to create on the fly some of the most common reports. So you can just generate a tree of all of the species of bats that have been sequenced, but also label the tips or in terms of this circular trees, just paint the categories with different colors, right? You can get any of the assembly metrics analyzed to see trends using scatter plots. You can get the rainbow or the arc reports to try to see the progress of sequencing. All of this you can do after a query, and then you click a button. In most of the cases, the report is there, and then you just tweak to show what data you want to retrieve. And then on the API, if you want to generate those links directly, you can. So there is an endpoint for those reports as well. But ideally, you want to see the data. You want to check with this plotting tools that we have. But if you have a better system for a better, let's say, package or tool for plotting, specialized in creating images, then just all of that data can be retrieved and you can use in your favorite tool, for instance. And then finally, GoaT is a web window. Over time, it became the place where you go to see the Earth Biogenome Project projects. So we created a session that is dedicated to all the projects, sequencing projects, usually the large initiatives from the Earth Biogenome Project. However, there are some projects that are not affiliated for political reasons or any other that we can get together. And also some of the data that are from projects in more restricted websites, whenever they make a subset public, we can treat them as proxy for projects, and we can also display here, and then we can see, for instance, in the whatever is open access in the Chinese gene bank database can be retrieved in GoaT as well, not only the NCBI data. But anyways, so GoaT Web is a window for these EBP projects. There is a list of affiliates. You can click on each one. We have project dedicated pages, and you can access and start hovering and clicking around to see more information about each one of those projects, including progress in the sequencing and completion, right? So far, so good. Do you have any questions? Yes. Okay. So I'll start trying to talk about what types of data GoaT stores, but already kind of tackling one of the most frequent asked questions. There is, well, the difference between what is direct versus estimate, and then what is planned and in progress versus done. So the first category is that the types of data that are things that are done, that have been recorded for species or that have been recorded for assemblies. We have assembly databases. Most of our data is coming from the INSDC, which is the collection of this DNA sequence repositories, right? We have the ENA, that is the European, the Japan, and then the NCBI. So they are all integrated. We retrieve the data using the NCBI datasets. Sometimes some of the ENA, we kind of feed GoaT with all of the different data stores that they have. We also pull some data from the Chinese Gene Bank and JGI. These are the ones that I say that not all of the genomes are publicly available. So we take a subset of the public data and we track on GoaT as well. But these are, in most of the cases, this bring information about things that have been done. So has so-and-so been sequenced? Yes, this is all the metadata. And then we retrieve all of the metadata related to those. The other type of of sources that we go for is some of the analysis. So these are also about done sequencing, right? If there is it's usually contamination and sequencing stats, so the quality of an assembly. And these are all linked to the assembly. And we have all of the assemblies that are publicly available in GoaT. So that's another one. Also, there are some of the analyses we can actually import from any source, as long as they have a table or a JSON or a data structure that allows us to import. But yeah, so for other data portals, for instance, the VGP Genome Arc, if there is a place where they store the quality values for the assemblies, we can go there and we can pull that information and store in addition to the quality scores that we have on INSDC. And then finally, we have these specialized databases, and these are used to compile all of the information that you have for specific taxa. So it's not necessarily out of done sequencing, but it's done some other form of study. So chromosome number usually comes from cytogenetics. So we have chromosome number, ploidy, sex determination. There are some databases for or lists of threatened species, so conservation status. All of this can be aggregated. So when a project decides to sequence something, they can go and see everything they need. Can I collect the species? What documentation would I need? In which of the lists, conservation lists or government lists, the species is present? Does it occur in the country that I'm interested in sequencing? Has it been reported there? All of these can be retrieved from GoaT before even you plan your sequencing project. And then towards the end, you have the genome size that helps with the sequencing efforts, chromosome structure, all of that helps you understand your assembly a bit better and curate your assembly better. So this is the first source of confusion. What are the estimates then? What does GoaT do that it creates a bunch of values there that sometimes are not that accurate? So GoaT has also estimates for, especially for these numeric types of attributes. So let's say that you have a bunch of species here and a lot of missing data, right? Everything in green here is data that is available. So for genome size of a species. And what GoaT does is, okay, let's spread a summary value for those observations back in the phylogenetic tree. So it gets populating the ancestral node, right? And then what GoaT does is this measures, so usually for genome size, in this case, it would be the median of all of the values. It goes back and it populates the most recent common ancestor of all of the nodes until they get to the missing ones. So let's say a species here that doesn't have any value for genome size, it will pick the value from its most closest ancestor with some other taxa that do have that information available. So in this case that we have another group here of species that let's say it's the same genus, but they don't have any information on genome size, they have to go back and then pick the information that is shared with the other taxa, right? So you know at which level, and then because of that, what level of confidence you have on that estimate. So estimates are very different from direct values, and each estimate is done by attribute. So you have one column for genome size, the estimates are calculated every single day for that field. Then you have another for ploidy. It will be recalculated every night. The more the data that we input there, every single day, it will be revised and recomputed and displayed. So although the direct values don't change so much for a species, for a clade it will, and then it will help populate more these missing values and these estimates. So over time, the expectation is the more data we input on GoaT, the closer to reality it is, and then you can make informed decisions with this data. Okay. Then we have done sequencing versus plan and progress, right? So done sequencing is what we retrieve from the DNA sequencing repositories. So NCBI, Chinese Gene Bank, JGI, Genome, these are all done. Once we have an assembly accession, we can already import it into GoaT with all of the attributes that are linked to it. Nobody has to do anything. It's happening automatically every day. But we have also the plan and progress, and those are a bit more tricky. What GoaT tries to do is to update those every day, but we are really tied to what you can see here is a formal list with a controlled vocabulary for the target status and the sequencing status. So each project on the BP network, they will have some system, either a live spreadsheet or their portal will have data that will have pretty much this information. That's all we need from the projects. But we cannot have the updated data unless they update. So let's say that they have this list of species that they want to sequence. You can see here that some are priority. I'll explain what they mean a bit later. Some have been collected and some have not started, right? If they delete half of this list, GoaT has a way to pick up overnight this change and then remove those deleted from the live list. So any changes that they make on the update, GoaT can pick up. But GoaT is not responsible for creating these for them unless it is really the done sequencing, because then we are taking from another source, NCBI, and saying, okay, this has been done. This has the identification for the project, and we know that it's probably the same target that they have. So we can still have some up-to-date results of things that are done based on just completion, complementing the different sources. So far, everybody okay with it? Any questions? If I'm going too fast, also please stop me. But yeah, so what usually I was responsible to do, and now I'm trying to share a bit of the responsibilities with Fang and other people, is to actually write the projects, make sure that they have their lists up to date, see if their sources are fine, maybe help them with a bit of the glossary and then this specific ontology that GoaT uses. But that's pretty much it. It doesn't have to be a live spreadsheet. It can be a portal. So for ERGA, for DTOL, we already have many portal-like sources that just get in sync with GoaT. So, okay, we get all of that information in, but then how do we attach it to what we need to search, right? So we have this data attached to what we call indexes. And the indexes for GoaT are taxon, assembly, and sample. I'm not going to talk about sample because this is a feature that is in progress. But for instance, if I get from NCBI all of the metadata for an assembly, this is going to be linked to that entity. So assembly is the index that I'm talking about, and each assembly will have all of the metadata associated with that assembly. This is a bit different than the taxon index. The taxon, let's say that I have a species. I have multiple observations, multiple assemblies for that species. So all of that group of assemblies, all of the metadata for the group of assemblies will be linked to the taxon. So you see that the taxon actually, instead of having one species name to one genome size, you'll actually have one species name and a collection of genome sizes. So there is the need to show a little bit of summaries, right, of either direct or estimate values, depending on how far you are in the tree. For species, people usually observe the data at the level of species. But for genera, for instance, I can say an estimate for genome size of a genera. Or I can report as a summary value the best quality assembly level there is for a species or for a genus, for at least one species within a family. So all of these is the types of summaries that we have for the taxon attributes. And then here we have on GoaT YouTube channel, a bit more explanation and showing how to click around to find information in different indexes. So, okay, enough about a lot of this explanation. What I wanted you to do is actually go to the GoaT UI and try to copy the link for you. So I pasted it in the chat. Hopefully it's working today. Are the servers okay today?
As far as I'm aware, but that loading is giving me a concern. Oh, there we go.
It gets really slow whenever we are doing the live demos, just because I have all of the different GoaTs open here. But yeah, so what we're gonna do is, so this is the GoaT web, the GoaT UI. I'm trying to increase the zoom, but I can't. All right. Can everybody see my screen okay? Yeah. So just go to, usually what I do is let me do this. I usually share the screen side by side with the instructions versus the page. If you can do that. And then if your system does that, you can just go back and forth. If not, you can keep my presentation as the main screen, and then in another tab do the GoaT UI. I make this smaller a bit so everybody can see. So, okay, where am I? Here. So in the presentation yesterday, I went over all of the components of the UI. So when you get to the landing page, you'll see that there are all of these tabs up here. They're all clickable. Today, I'm not going to go explaining every single one, but only the ones that are really useful for today's tutorials. So the main GoaT here is the place that you click when everything goes wrong and you want just a clean slate. Click on the GoaT, it will just refresh the landing page. That's the main page. And you can always use the button to clear all whenever something goes wrong. So let's say that I just paste some nonsense here. I can always click on the GoaT. It'll take me there. There will be still a record of what I was trying to type, but you can just clear it all. And just make sure, just click on the GoaT again, everything is fine. The second thing that I want you to see is that there is a tab here for projects. Well, actually, search and help, you can click on top of them and then go redirected to the different sections. But the projects will have the EBP main page, or a list of the EBP affiliates, a list of all of the projects, including other that are not EBP, and then this region section for projects that just have some summaries by country. You can select a country, and then, for instance, see how many chromosome level assemblies there are for species that have been recorded in that country. So not necessarily that species is going to come from the country itself, but it occurs in a country. So most of countries will have dog, let's say, in their list as count. What else here? And then finally, you have the user settings buttons. I'm gonna go over in detail later, but it's just so you know that it exists up here. And whenever you use the page, you'll always have the settings on top of your table. Then there is another side of GoaT, that is, if you scroll down all the way to the bottom of the page, so I'm just gonna return to the main the landing page by clicking on the GoaT here. If you go down, you'll see that there is some examples of the data and then data summaries that we have. But all of this and the bottom of the page, it's actually clickable sessions. So for instance, you can see what was the last release date for GoaT. Sometimes, usually it happens every single workday, but sometimes if there is a problem, then we just keep the previous working version live. So if you come one day early in the morning and it's not the date, it's gonna get there eventually later that day. And then here you can click for color palette, which is just a way to just pick your favorite GoaT colors, right? Some of them are colorblind friendly and you can always use them. You can click on those, and this is particularly important to report an issue. You can always create a new issue if you have GitHub to say that something is not functioning as expected. And here there is a button to generate QR code for the pages, and we're going to be using them later. But any page any code can be generated for any search, so then you can share with other people. All right. So why do we have the project pages, right? And the EBP lists and at all in GoaT. So the idea is every single project across the globe that is tied to the EBP, it will have first its own scope, it will have its own identifier, its own list of species that they are targeting, and then they are actually progressing. But it would have to go to each one of their portals to try to understand what's going on and who to contact in case that, oh, we also have a sample for that species and we want to solve duplication. So what GoaT does is create a place that just shows you an overview of what's going on. There is always the information. So if you go to the projects, there is always information here. Let's click on that 1K, for instance. What is the acronym that GoaT uses? The name of the project and the bioproject ID. This is the ID that you use to identify, to retrieve all of the done assemblies from NCBI. So if you click on a project page, it will have the GoaT search term that actually teaches you how to use search nomenclature to retrieve all of the species. There is a little bit of information about the project, usually about the scope, link outs, and then most importantly, the main contact. So if there is anything that you want to collaborate or solve duplication, you can, right? So this is why the page is there. Yeah. So with that, we have the first set of exercises. Usually it helps me if I can see your faces. I know that we are streaming, but I think only my face appears in the chat. But if you are comfortable with it, feel free to open your camera. It's just so I can sense if people are understanding or not. But it also can scream outside cameras if things are not very clear. But the idea is just to follow the steps. Try to follow these steps on your own on the exercise, for the exercise. And then I will go over those steps with you, showing what I think it's important. And then you can ask questions about it. Right, so I'll give you 5 minutes just to go with this with this exercise number 1. So it's to open the Earth Biogenome Project page, hover over the reports, open the reports and interact with them, and then follow a set of instructions here just to get somewhere. Because usually what people do is that they get to a page, they see a bunch of stuff, and they'd say, okay, what can I do with it? And so let's explore it a little bit more to see what you can get out of it. And of course, if you have any questions during the process, I'm here too. Oops. I realize I'm mute. So there is a question on the chat that for step F, she's not sure what I want her to alter. Okay, yeah. So if you go to the, oops, you see up here beside the search box where it says taxon. Of course you don't. Let me fix this. Yeah. So where it says taxon here, you can always click on the drop down, click to in assembly, and hit enter. Is that it? Let me just double check. Oh. Yeah. Okay, 5 minutes. Maybe I should just no, not change what is written on the search bar, but change the what did I say? The button. Yeah, just the drop down in the button. So I'll go over this very quickly just to show you. If someone didn't get there and have questions, feel free to ask them. You can also post the questions for later in the Discord for the ones there. But yeah, so if you go to the EBP page, you have the description, you have a bunch of things. It's still using my palette colors. I'll just go back to maybe this. Yeah, that's the one that you usually have. So the first thing you'll notice is if you hover over the reports, you can actually start seeing some of the data already. right? If you click over the rainbows, this is a rainbow of progress of assemblies out of all of the taxa there are on INSDC taxonomy, this NCBI taxonomy. Here, the second rainbow is the one that is specific to the Earth Biogenome Project. So when we say EBP umbrella is actually all of the species or all of the taxa in all of the levels that have an assembly with the bioproject ID of Earth Biogenome Project. So this bioproject ID is just an identifier that is used to group every assembly and link it to a project. So interact. So you can open it to expand it using the arrows. You hover, you can see actually the real values for each of the sections. So you'll see there is a bunch of over 3,000 species with an EBP genome. And this is an underestimate because some of the projects still have to create their bioproject identifications. So you can pick one of the levels and then just click on it. And what happens, sometimes you have to scroll, but usually what happens is that you get the results of that level. And this is really helpful for you to start getting used to the syntax that GoaT uses. So in this case, we have 2304 hits because actually I clicked on the genus. So they are in GoaT and usually on INSDC, 2304 genera of eukaryotic species that have an EBP assembly. And then you can see here that there are ways to, this is the way that if you went and opened a new GoaT and start from zero, you could just type this. If I would actually put assembly type, but that also works. If you put assembly span, it means it has an assembly and it has an assembly length. That's what assembly span means. All of the search, they are linked by connectors. So usually it's and in between attributes. And then the bioproject is equal to the number, the identification of the bioproject of Earth Biogenome Project. And then tax rank equals genus. You will see that most of the attributes that we have for tax, the taxon, they come on parentheses instead of equals, because this is not really an attribute or a value that we are collecting from a database. This is actually our index. So here it is, you have all of these, a summary. You see that all of the values here, they are from descendant taxa, of course, because the assemblies are linked, or the genomes are linked to species. So this is a summary saying that at least one project has sequenced this genus here. But here, if you can see for trifolium, we have over 30 total bioproject IDs. That doesn't mean that it's all projects, right? The initiatives, because each assembly also gets its own bioproject. So bioproject is a collection of the species, bioproject ID. If there is other data also receiving bioproject, it gets linked together, like RNA. I think they have their own bioproject. I'm not really sure now, brain. But for sure, there is the umbrellas. So let's say that this was we have a bat that has been sequenced by the EBP, and it has been sequenced by the BAT1K. So BAT1K is targeting all of the bats. It will get if the BAT1K actually submits an assembly, it will link to its own bioproject. But because bats are vertebrates, and BAT1K is collaborating with the vertebrate genome project, some of the bat species will also receive the bioproject ID of vertebrate genome project. And because both of those projects are affiliated with the Earth Biogenome Project, you'll get the bioproject ID of EBP. And the way that you can go about it is just if you click here and you hover over, what is it? Is it in taxon? In some of the fields, sorry, not for this one, but I'll show you later. If you Oh, because this is an estimate. If you hover over, you will actually see the name of the project that is linked to a bio project. But I mean, right now we can identify here. This is the Earth Biogenome project number. Anyways, so it was here, and then the next part was search box. That's what you see. So an assembly span, all of the bio projects, and then change this. Instead of taxon now, I'm looking for assembly, right? So I change to assembly and I click enter. What have I done? I'll go back to projects, EBP. I clicked on genus. I changed to assembly and I hit, oh, I know what I did. And I hit enter. If nothing happens, it's actually a misunderstanding of my part, sorry. You see that here, I'm looking for tax rank genus, right? But I have to include the descendants to be able to pick up the data because the data is linked to the assembly. So I need to hit here, include descendants, and then click again, I think. Of course, because it's a live demo, things go crazy. Go to query builder. Let's go, we went back to taxon. Let me try again. Did you get the correct behavior? These are the types of things that if things don't behave exactly as you expect, and it did before, these are the type of things that should be reported, I mean, to the GoaT team, so we can work on why we are getting some different things. So here it is again. Done. There is a question, yes?
Sorry, I had the same problem. You had bioproject, you had a bioproject link there as well. If you remove your bioproject, then you will get to the right link.
But it shouldn't, because okay, here, blah blah blah. So if you should just be able to hit assembly. Because bioproject is also a
你怎么自己去看病啊？是吧？我不想你打这些。
Hello?
Oh.
Yeah, so see, in this case, I was already in the species rank. So maybe for assembly, you have to be on species. I'll write that down to fix it. But if you clicked on the arc for species, then you went directly there. And then what it shows is, again, now, of course, I have the scientific name, but the main index for this part is the assembly. And then if you look, we won't have the estimates anymore. We'll have the data that we're looking for attached to the assembly. And if there are multiple assemblies for a single taxon, they each appear, oh my God, you see for this Hippomelta, you'll get the data for each one of the assemblies. Right? Did you get there? All right. So the take-home message here is that the EBP page, it collects, right, information about done assemblies via bioproject ID. So this is the main, even if you click just, if your search was just this, it would get pretty much the same information. See? Because it doesn't matter. We are looking for something that has assembly span, but of course, from INSDC, everything that has an assembly ID will have an assembly span. That means the length of a mounted assembly. And then clicking on the reports reveal the search terms on top of the page. So this helps you understand what's going on behind the scenes. And the taxon and assembly queries will not have the same number of results because one is going to show summaries for a species and the other one is going to show each entry for an assembly, right? So if you go to the exercise 2, it's just to show that when you're exploring these project pages, there are things that you can do that not so useful, but you can start tracking to expand things and try to see the data in a tree, right? Because the name is Genomes in a tree, you should be able to see a tree. So if you go to EBP again, what we have for EBP here is a tree that shows all of the, well, it's not phylum, it's all of the eukaryotic orders that have at least one species sequenced by the EBP. That's why everything here is orange, because it has at least one species within that order with the bioproject for EBP. So if you go up, you'll see it's a lot, but just select one. You can do, I think, directly on the name of the group. But if you click and hold, the results update to that clade. If you click on a node or if you click on a name. And then you can actually start looking at the trends inside, I don't know, a clade that you want to expand. So what we have here is, let me make this bigger for you to see. What you have here is just, before we had a tree, then we click and hold, then you will already get the metadata for those clades, and it goes in a stepwise manner. So before we had the orders, right now we have the families. Let's say that I want to know more about this one here on top, and I click and hold, then I can see that there is, well, one genus that has sequenced by the EBP. And remember, this is getting updated too. So then you can see that the tax tree now is this family, the tax rank is actually genus, and it's the bioproject. You keep going, and this is actually a bar for a summary for the assembly span for that taxon. So it's not necessarily coming from, it's coming from all of the descendant assembly values. And if you see, it says 30.6 meg, but it has a range. This range means that there is at least 2 results for that estimate that allow that estimate to be generated. So if you keep clicking, eventually you'll get to species. You'll see that there is still assembly span for several, and this is pretty much where you get when you click on the trees. You get to an entry. In that case, it was the only species within this group that was sequenced by the EBP, but you also get a bunch of information here. If you click on the name of the species, you go to the records page that has, it's one page dedicated to that taxon and everything that GoaT has on it. If you click on, hover over or click on the values that are on the display table, then they expand and you can actually see that, okay, for this species, this is the taxon ID. I clicked on the assembly level chromosome. It has primary value. The summary value for it is chromosome, but it is the primary of 3 direct values. And hence you have one assembly that is chromosome. It's been assigned as the primary for display. It's the one that you see when you perform a query. And then there is another one that is config, another one that is scaffold. If you click on them, you can actually get to the submission and then get more information directly from the source. It can be ENA, it can be NCBI, etc. And then the same goes for any other column that has been selected. But as you can see here, I don't see assembly span. Oh yeah, here. Assembly span here is 33.2, but again, this is the median of the observed values. And this one is shown as the primary. Well, whenever it's primary, that's the value that's going to be showing up. What else? And then for genome size, you see that the bar is red. The closer the genome size is to the assembly span, the more accurate the both are. But in this case, the assembly span is estimated from ancestral taxon, which means that no one went ahead and got this species and did a flow cytometry to measure the genome size from using a cell-based method. So if you click on it, you'll see that this is the median that has been used, calculated for all of these, and it's coming from the family level. So we have at least one ancestor at the level of family in common, that one species at the level of the same family that has a value for genome size. And that's the value that is being pulled here. So if you look, if you click on it, all of these arrows can be clicked and then hover over to understand a bit more what's going on. But yeah, we have two species within the same family that have direct measurements for genome size. And that's where the data is coming from, right? So you can tell that whenever it comes to estimates, the more we include, the more accurate it will be. But the goal is for everything that has a direct measurement, if you compare assembly span with the genome size, they should be similar, except that the assembly span usually is a lot, it's less, I'd say it's smaller, because the genome size is more accurate, because it's cell-based, it really measures the DNA content inside the cell. So it's counting all of the repeats, everything. And then assembly span is not. Sometimes we have to get rid of things. Okay. Anybody has any questions for now? Yeah, so if you go to the project page of Darwin Tree of Life instead now, we'll go to projects, ABP affiliates, and then you can find the DTOL, should be Darwin Tree of Life. You'll see that the project pages of specific projects, not the main umbrella aggregators, they have a slightly different type of page with specific information that is not just based on data that is done. It also has data in progress and reported and planned. But if you go to the tree now, this is the case of all of the phyla that is targets by DTOL. And then in orange, it's the taxa or the phyla. They have at least one species sequenced by the project. So when you expand it, it's slightly different, because you'll see here different colors. This is still assembly span, but the colors mean that there is data by DTOL versus there isn't for the names. So if you click on, let's find a good one, Porifera. If we click on Porifera and hold, oops, it'll show that out of Porifera, there are some species that have assemblies, but then this, not species, groups that have assemblies, but in this case, only the orange one has data by Darwin Tree of Life. So you can keep exploring and expanding until you get to the species. But I hope I get there. Yeah, so see there, within this genus, DTOL is actually targeting all of these species, because this tree was made actually not using the bioproject. The base of the tree is all of the DTOL target species, or species within the scope of DTOL, potential targets. And this one has been sequenced. And then you can find the bioproject of DTOL is right here. It's a chromosome level assembly, blah, blah, blah. And then you can see that it's actually shared between the scope of several other projects. Anyways, that's how you get the data for it. And that's how the tree in the project pages that have a target list differ from the ones they're aggregating. So EBP, ERGA, the global ERGA, they are all big umbrellas. The GIGA, that's the Global Insect Genome Alliance. Also, they are aggregating things that other people are declaring as targets. So it depends on the up in the GoaT page. But usually we'll have both, the aggregator and also the specific project. Did everybody get a chance to click around? Yep. Fine. So let's go to source of confusion number 2. I think I'll have to close this one for it because it's gonna take a bit. Oh, I didn't know I could do this. All right. Can you still see my screen? So for the project pages, we have usually 2 sets of attributes from the projects that we request. And one is the target list, and the other one is the sequencing status. They are all imported into GoaT originally as 1 column each. And then GoaT starts distributing all of the values to create more attributes. It will make sense in a bit. But for instance, for target list, we have 3 terms that GoaT uses. They are under revision, actually. This is going to change because long list, I realize, doesn't mean a lot to many people, except for the GoaT team. So this is actually all species within the scope of a project. They are not all of the species that the project is going to sequence, but they are a list of potential targets. The other priority, on the other hand, is a list of it will retrieve, if you use that term on GoaT, it will retrieve a list of species more likely to be sequenced by the project. So if you have real plans, that's the tag that you put on the species. And then finally, the family representative was kind of a special case for the priority, just for the projects that are doing the taxon, like the massive projects. They have to pick one of each family, then one of each order. So it makes easier for them to track the progress, the sub-progress, right, of in a taxonomic rank kind of deal. But one of the things that I get a lot is that people complaining that now this massive projects in the EBP network are claiming the species that I want to study, and that's it. What should I do? Is that like a DIBS system that it's like, okay, now I claim this and I sit on it and I'll be forever trying to sequence it and nothing comes out? And then the answer is definitely not. So the way that GoaT is supposed to be used and the way that the EBP projects agree to get their data into GoaT is that they will have a scope. So that's the long list, right? Because first, if there is smaller lab or even another project within the EBP network that has the same scope, they could early on detect that there is this kind of duplication. So they can negotiate, one drop the species, the other one continues. Or there is someone that contacted me from Brazil with a species of spider that I have on my list. I never even collected it, but they did. They have the ability to produce the high C, high quality for the project. Can they join my project? Well, it's up to the projects to decide, but GoaT is there, and then they receive these lists to just facilitate this kind of arrangements, right? So seeing that a project has a species that you have interest is not keeping you from doing it. It's actually, how do I say, not fostering, but incentivizing you to contact the project managers or the people that are sequencing that to see if they need anything, if you can help, if they can help you, right? And being affiliated with one of these projects is actually a good thing. So if you have a small lab and you want to sequence, I don't know, 5 species, it's not a lot to become a major project. But if you publish them on the idea is to get them released together as a single Cibele's lab bat species. Why not contact BAT1K, since I'm already doing this species anyways, and tell them, hey, you don't need to do this because we're already doing. Or are you already doing it? We can negotiate what we can do. So this is the main goal of GoaT. It's not gonna select things and say, this is a done deal. It will show you what's up there and then make project managers, project chairs, data managers make decisions on who to contact and how. And then we go to the next source of confusion. I really want to get rid of this, but now I can't. I thought it was the greatest feature there is. Oh, yay, right? Yay, okay. And then that's the other source of trouble. So I'll try to explain as best as I can. Please tell me to repeat if it's too crazy. There is the other source of information that I get. Usually from the projects, they only have to fill one column with a lot of options. But this is all controlled vocabulary. If they can provide this, it's perfect. But mainly what you can see progress over time is sequencing status, right? And this attribute here is one column. But remember, this is not sequencing status of one specific project. This is the sequencing status across all projects and even across INSDC for a species. So it's a summary for that species. It will be a value there that shows the further stage reached for taxon across all of the EBP projects. So if it is, I know there are 5 people doing this species for some reason, and one of them already is in progress instead of sample collected, then it will show as in progress. If on INSDC or in GenBank there is an assembly for it, well, actually, in this case, it's only across the projects. That's what I'm saying. Now, I had to create separately sequencing status and then underscore the project acronym. If you want to look at a specific point in time for a project, that's where you go. So the values that can be here, they go from the lowest, that is a sample has been detected. So it's sample available. It is present in a zoo. There are plans to get them from someone that knows how to breed them. They are under culture, but I don't have them yet. This is sample available. Then let's say it's available also in, there is DNA, high quality DNA extracted in the GGBN, how to say, repository. So there is a way to identify who has a high quality DNA sample for me to use. This is sample available, and I'm not like. Then you go to sample collected. So these are all values. If you say sequencing status equals sample collected, you'll get, wait, I'm ahead of myself. If you say sequencing status column for a species, you'll see one of these values. So it shows progress over time, right? Sample collected is someone went to the field or lab, collected the tissues. Sample acquired means the sequencing center responsible for performing the sequencing. It can be the same institution as the collecting one, but it acquired the samples. Then it goes to in progress, which is comprised of data generation, which means lab work, and in assembly, which is in silico analysis, right? The actual assembly, curation, blah, 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 if you have them. And we have both, so we have both in case the project wants to disclose. We might have even more detailed for high C, for PacBio, for blah, blah, blah. But for now, these are the 2 levels of sequencing status that we can report for project, right? And then it goes all the way until assembly is submitted. Once it is submitted, or even before it is submitted to NCBI, you can have it actually open. So if it is on INSDC, of course it is open, but sometimes you have it in a bucket. So like the genome arc. All of the vertebrates assemblies for vertebrate genome project, they are already available on genome arc openly for all of the members, and might even be open for other people that you can go, actually it's fully open. You can go and retrieve data itself from them, even before they are open on INSDC. Sometimes they are released in the same day, but still. And then you have INSDC open. That means it is open access in one of the INSDC databases, which are the NCBI, the database of Japan, and the ENA. And then finally, so in this case, remember, open means openly there is an open assembly in the Chinese gene bank, but not on INSDC, maybe not. And INSDC open means it's open and it's open on INSDC. So anything on INSDC is also open. Sorry, that's what I wanted to say. And finally, published is there is a genome note associated with it or a publication that actually describes for the first time the genome. So it will be the first publication of the assembly. So far, is it clear? So when you are looking for sequencing status, you will always get the further sequence. So it is time dependent. It will change over time per species and per project. However, GoaT also creates these columns that have the name of the specific status. And that's a completely different type of query. It's not dependent on time. So if you look for in GoaT, sample collected, and you will retrieve all of your carryots, you will see a list of projects that have ever collected that sample. The type of question is actually different now. It's not what is the latest stage for a species, but has the species ever been collected by someone? And you'll see all of the project acronyms there that correspond to that search. So these are actually the same values, but now when you're using the query, you can create a subset of refinement to your query. Let's say, I want everything that is in progress by DTOL, that has been in progress by DTOL at any point in time. So what projects have sequenced my cat? Then you'll find all of the projects that have ever declared cat as in assembly or open, right? Yeah, so if you want to know if the preliminary data for project blah, blah, blah is available for analysis, you're likely to retrieve that data more easily going open equals VGP, let's say. So it will show all of this, a list of species that is open in Genome Arc, then to try to go sequencing status, blah, 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 until you find, right? Or you can go to sequencing status underscore VGP equals open. Then you also retrieve a list of species. So it depends. It's just different ways to see the data depending on what you need to do. Yeah, and then which projects potentially have the sample I'm looking for. I don't care about the status. I just care about sequencing sample collected. So I just hit there eukaryotes or turtles and sample collected. You get a list of the taxon and a list of all of the project acronyms associated with them. So there's someone to contact, right? So that's it. This is actually source of a lot of confusion. So if there is anything that is not clear enough, can you please let me know? Because this is the part that I'm trying to create a way to explain that makes sense for people. And please interrupt me at any time if you think of something that I can improve with this, because this is actually very critical in GoaT and the users. What did this say? How? So it's been an hour and 15, right? Can we have a quick break now before we move on to the next exercises? Because I think they will be a little bit more complex. Then maybe 5-minute break for quick bathroom and coffee. All right. So I'll be back in 5. See you in a bit. Hi, can you still see my screen? Okay, I didn't know you made a sound.
No, I thought I'd give it a go. It surprised me
It's-
as well.
It is really nice. Okay, okay, welcome back. Now is a part that I was thinking how to best do this without having to repeat all of the tutorials for the UI yesterday. So I decided to do this instead. This is a kind of a cheat sheet for you showing the components of the GoaT search. It has the buttons, kind of explains what it does. I don't expect you to use them today a lot. I'll show you when you need to use them. But this here is the video for the tutorial from yesterday. And then you can just, you click, you should be directed to the talk. Oh my God, yeah. So I hope that's enough, especially for the first time users, but let's not stay here for too long. I don't know what I did now that I have a tab. What have I done? Well, he wants to stay like that. He won't stay like that.
I think you're in presenter mode rather than presentation mode.
Weird, huh? Slideshow. I
There
think
we
it's
go.
because of the link out. Anyways, so now are the actual questions that you can answer using GoaT. A few examples. So just open your GoaT UI and you can just follow and type stuff that you can see on the slides. So this is just an example of a list, retrieving a list of all of the potential target species for a project. So you can, if it's all the targets, all potential targets, we're talking about the long list, right? In this example here, I chose the ERGA BGE project because it has not as many targets as DTOL. Tree of Life has 70,000, so it's harder to see all of the data. But pretty much what you do is that long list equals the acronym that GoaT uses for the project and tax rank species. And one thing you have to remember is that back in GoaT, when you go to when GoaT works, oh my God, what is going on? No, it's there. If you go to the tab for the project, I think for me it's gonna take longer to load just because of the Zoom and the live. Yes. So if you go to projects, you'll get a project list, right? And any project that has data on GoaT will have its acronym as the first term here. You don't even have to enter the project. This is the name, so you have an idea. Whenever the acronym of the project is different from the one that GoaT uses, it will be stated right before the project ID. So in this case, you'll see here that you get all of the long list with the project, and then you select the tax rank that you want. So this is the way to retrieve what are the target species or are the potential targets of a group of a project. If you want to get the ones that they are more certain to be sequencing, you just replace this long list here with the other underscore priority. And when you start typing, if you have a blank search box, whenever you start, GoaT will try to autocomplete for you. So you can just click on whatever it's suggesting. The only thing to remember is that if anything starts with tax underscore something, it will be on parentheses. And then if it is an actual attribute, you'll have to receive equal. Well, there you go. Here is a list. And it comes with the default of some columns here. They are what usually the people that work with metadata want to see, but that's not necessarily what you want to see, right? So my recommendation is anything that you want to see, if it's not too general, you can put, let's say, if you're looking for the long list, all you have to put here as a column for display is long list, if you don't want to retrieve any other data together with it. So I'm gonna do a demo of how you can customize your search results. This is the part that you follow along. So if you go to the slides, maybe if you don't have the slides, I'll just give you the link. I thought that I had the link. So if you go to GoaT and you go long list equals something, and the nice thing is that you can actually edit something that you did before, and it's not that bad. So long list detail, add tax rank species. I'm gonna put erga BGE here. Yeah, I'll have it done. Yeah. Yeah, so it's completing for you, long list, then equals erga, let's see, BGA, and tax rank. That's right. So these are all the species, a list of all the species that I got for the taxon. What you can do is the step of the tutorial there is click on result columns and exclude everything that you don't want to see and put in everything that you do want to see. And this is person or user specific. If I'm usually interested in just the sequencing status, I'm gonna select the column for sequencing status. But this way here, you can get the list, complete list, and then just display the columns to see the data that is attached to it. So let's say that I don't want to know about anything that is not assembly. So I have assembly, level, and span is enough for me. But I also want to see who is sequencing, who has it in priority, and then since it's erga BGE, I can actually find the sequencing status that is specific to erga BGE. And if you scroll down, you can show the sequencing status, the general sequencing status for, I think it's all the way up. Yeah, sorry. Sequencing status. So if you hover over the options, usually you can see a bit more information about it, which project it is, right? So AGC doesn't mean anything for a person that is just coming here, but if you hover over and then you understand it's the amphibian consortium, and then you just pick them and update. So now what you see is that I still have my 338 species. They are targeted by BGE, but now I have a lot more information about it. You'll see that for a lot of them that they don't have assemblies yet, the assembly level is empty. You don't have assembly span direct value, you have all estimates. Then you can see the sequencing status in general. So that's useful because I can see that if it matches my project, if I'm the data manager of erga BGE, I want the sequencing status general to be my own, but I also want to double check, right? If I choose other attributes, who else is doing that? And the way I do that is using either the scope or the priority list. So visually, you can just scroll down and see, okay, this is probably a red flag here. There are two species, two project acronyms, sequencing the species. So it's in the other priority for BGE and also the Catalan project. But in my case, it is in assembly. Maybe I want to select the column for the Catalan just to make sure that this is the only overlap. Or I could just click. Remember, you can always click on things and hover to get more information. So if you click here on the CBP, it takes you to the GoaT page of the CBP, where you can find the information of their data manager. This is myself, if I'm BGE. And then source, you see here .4. Well, from CBP, I'm getting this from a single place. There should be a there should be a link to the external source for here. I'll fix this, but usually you can go to the original place if they do have a data portal. What else can I do here? We see the exercise. Oh yeah. So now that you selected your favorite columns somewhere here, yeah, right? Yeah, ErgaBG, I want to know only about ErgaBG. I can just click here to add the search to the favorites. And this is critical for, I guess, saves you a lot of time. So you don't have to type and do all of this again. If you are a project manager for one project, you can always have your baseline query as saved here, because every time that you click, you can retrieve, you open GoaT, you can go there and retrieve exactly this layout, including all of the columns. So if I open a new GoaT here now, it's just, oh no. And I go up to the search settings. Now, of course, I have too many, but see here that my latest favorite was long list ErgaBG and taxonomic species. It's showing here exactly what I typed on the search box, what type of index it is, the size of rows, how many rows I want in the first page. Sometimes I just want to see 10 so I can scroll down faster. So I can actually even change this. And then all of the fields, so each column that I selected, you can click on the QR code and select, generate a QR code that you can share with people. You can actually edit your query. Let's say I just want to add one column quickly, or I don't want taxonomic species, I want genus. I can just edit, but I can also click search. And then that's going to take you to exactly what you did 5 days ago, a month ago, doesn't matter. As long as you're using the same browser, the same computer, I guess, right? It's user based. All right. So this is the exercise, just so you know how to find again your query. There is here another place where you can check what it is. I just took a screenshot here for you to see. And you can also use other buttons that we have on the UI to display things a bit better. This is in the tutorial yesterday, but I thought it was nice to show you this guy here. So whenever you have a search, let's say I did here, where is my search? Something is happening because here was, okay, here. There is the GoaT link for this view. If you want to get there. The links can get really big, but they are very descriptive. They have every information for you to generate that query again. For the people that actually read this weird gibberish that is up there, it actually makes sense because it defines where you go, what you selected, and what fields you're displaying. Oh, and one thing I forgot to say is that I actually said, if you're not a human and you want to say, retrieve this in an easier way, computer readable way, you just put API version 2, and then you can get a file that computers can work with. So you can use the curl command to retrieve the data inside the script, let's say that you have. But yeah, my point was the fancy button that allows a person to explore. It will load. To explore the data a bit better. Sorry, some things I do I can't control. So just in my head, since I was a kid, it makes life the browser load faster. Yeah. So here you go. You have this query, and then you have categorical data here. I have in progress, and I have a list of 150 species in this case. Don't mind this part here. I'm going to talk about it later. Because my query, oh yeah. But if you come here and you hit the toggle split column, magic happens, because then imagine that you have a list of 70,000 species, and you know that in progress, some of the roles will have more than one, some roles will have a single project, and you just want a big overview of which projects are sequencing, just at least the first 10 entries. So this is how you expand to actually see, like humans like to see categories, right? So it turns all of the values, the acronyms of the projects, into these dots that you can actually see. And it does that for the entire table. I think in theory you could just come here and download as a TSV. I'm not really sure if it placed the dots. I never tried. I don't think it does though. Yeah, it doesn't. It just gives me the table as it was before. Anyways, so this is a button that might help you visualize your data. And so we have 30 minutes for the session still, right? I just wanted to ask if anyone has questions. If you know that you usually are going to be looking for a specific thing about the projects, if you ask me with human words, I can try to translate and do the query right now. If not, then I promise that I will copy and paste in the discussion later. But I mean, if there is something specific you want me to try to do live, I can try to do it for you. And then you get the link that you can use forever. Yes, Nikki?
Hi, thanks. So I'm part of a South African genome sequencing project for biodiversity. And it would be nice to be able to check all of the different projects to see if they are working on specific species. So how do I select a long list of all the projects and not just one specific one, but you know, and then zoom in on a specific species, for example?
So if you click long list, this is saying it does have the attribute, and then you go with and tax rank, I guess, species. You can even refine it by, and then of course include descendants, because help me here. Species. So whenever you don't specify with equal, the condition that you are telling GoaT is it has to meet that. It has to have a value, at least one value for it. So if you just type long list with no equal and an acronym, you get all of the, and then the rank, right? It could be family or whatever. You get a list of every species that has a flag, a tag for long list. The other way is to do the other priority. That is, it gives you a list that is more certain. Because, for instance, the long list for Psyche is a project to sequence all the butterflies in Europe. It's just the records of butterflies for Europe. So they don't really know that they will be able to find all of the species. And they have a subset that they know they want. So using other priority, here is always the recommended. But see, it's still like 10,000 species. And then you can go to the result column and select exactly the columns that you want. If you want to see which projects are doing that, you just put other priority, remove everybody else. Maybe you're not interested in things that are already done, let's say. So if it has an assembly type, where is it? Assembly level. It means that it's sequenced already. It might not be to the standards that you want, but you can even refine that a bit more. So these are everything that other people targeted, but the ones that have an assembly level, they have been sequenced already. And if you see that assembly level here is not showing. So what you can do is even refine depending on what you want. If you want a list of all of those species that have already been sequenced, you can just put and assembly level. So the list will reduce to only the ones that have values here. If you want the opposite, you can put assembly level equals null. So, and assembly level equals null. All of these terms, actually, there is a place where you can see them. I'll show you later. So that refines your list for everybody. All the species in order priority by someone that don't have assembly level. But, well, I want to sequence also the ones that are only contig level. So I just put comma, that means or, in GoaT language, and put contig. So assembly level, null or contig will give me a list of everything that is not done or it's done to only contig level. And I didn't check the number. I don't know if it updated. But there is a way to check that by clicking this magic button here. And yeah, it's counting both. And then here, if you toggle the split or untoggle the split, you'll see anyone that has a long list with their priority. All of the projects and the list of all of the species in order priority. But I don't think you want to do that because what is your project aim?
So the aim is so part of this is to only focus on species that have not been sequenced.
In South Africa, or
it is only in South Africa. But there might be genome sequences available that was done by somebody else.
Okay, let me show you something much better.
Yes, please.
Yay!
So because to sequence these species doesn't help. We want to sequence those that have not been done, but they might not all be published, or they might be in the final stages. So it's something for us to decide. Should we spend money on sequencing it? What are our priorities?
Okay, so if you come here to projects, you can actually select this part here for regions instead. And I don't know the 2-letter country code for South Africa, but I guess Z.
Yeah, ZA.
All right. Oh, I guess I have to use the drop down. But yeah. So do you see here? Let me check. Yeah. So if you want to start from the list, from the tree, it would be okay too, but let's see. So this is all the eukaryotic orders that have been recorded for South Africa according to the GBIF repository. If you have another regional list, I can import into GoaT the full list, and then you cross-reference with all of the other data. That's actually the best way to start a target list, because you get everything that appears in your country, put in GoaT, find the list, and then you say, okay, this one is done, this one is in progress, and then you refine using the query your first draft list for the scope. Well, let's do, so these are actually, you can retrieve all of the species they are done, and some of them they are done with chromosome level, right? So these are EBP for assemblies that meet assembly metric. Let me go to this guy. I think it's more straightforward. You don't need to do that. I can create the link on the fly, but it's just to show you that how you would start looking for it. So if you see the full report, remember the exercise that I did before, that I said they might not be useful, but it actually is. You can click on the base of this tree. Horribly. Okay. Do you see here, tree of all eukaryotic orders with country list equals ZA? Can you still hear me? I think I froze.
So that list equals ZA, is that the sample origin country, or is that where it was sequenced?
No, this country list is the list of the taxon. Can you hear me? I think I froze.
Yeah.
Oh, and tax, let me go rank species. Okay, so what I'm doing here is getting the list of species that have been reported to occur in South Africa. That's the only thing I'm doing.
Okay.
But since I already had this pre-selected fields, it just decided to go for it. But yeah, so now you have result column. If I go to regional lists and click country list, you can actually see, for instance, here, I want to display all of the species that occur in South Africa, but some of the species, they actually occur in a lot of other countries. Here it is. If you do order priority and you remove the missing values, you'll see any species that occur in Africa, they are priority for sequencing by someone else. So this is their list. And you get a list of projects. So usually this is like the medical importance or the widespread species. But as I said, you can remove everything that has been done by deleting everything from the search that already has a measured value. So you don't even have to type anything. You just go per column and can refine your search based on what it has a direct value or is a blank space. So you can just do this guy. On the fly, you just removed everything that already has an assembly level. So now you have 1,048 species. Now you want to remove, let's add a new column here for in progress, let's say. Even better, for sequencing status in general. Update. Could you follow what I did here? So for the first one, I removed anything that had an assembly level. So if it has been sequenced at any rank, it's already out of the list. Now we have only 1,000. Now
Is
what
that
I'll
the
do,
missing values that you set, or is that the green one with the assembly level?
assembly, I use assembly, sorry, I didn't mention this. Usually I use assembly level as a proxy for it has a sequence, a genome sequence.
Yes.
Because if it does have an assembly level, it means it has a sequence. There is no head sequence. So yeah, this part is a bit tricky too. Thank you. So this is a list. I removed everything that is not assembly level. Then now I have a list here of, I added a column of sequencing status. Some of them will be green, some of them will be missing, right? But I just want things, let me remove this from, I don't care about the priority. I just care about if it has started or not, right? So you see that there are some that are not priority for anybody, and then the sample, there is a sequencing status for someone. So to retrieve a list of the things that don't have a sequencing status, so no one has ever even collected it, you just come here and you remove whatever is a direct observation. So it means you just want to retrieve a column or a list of species that don't have sequencing status. And this one also have a subspecies collected, so I want to remove the orange as well. So now you have a list. Yeah. Now you have a list of all of the species. Oh, it's the other way around. I think I created a mess. Sorry. But the main thing that I wanted to show you, I'll open a new browser to show it, is that you can use as baseline the country list and then start removing things from the list based on what you don't want to have. So let me put it here. I think it's going to be easier for me just to do it in a new browser. Yeah. So 12. I will reset all of the columns. Assembly level. I'll leave assembly. Okay. So this is really clear, really clean, I guess. This include descendants. Every time this happens, I just go to a new GoaT and try to start from the beginning, because one of the things that currently we have to troubleshoot, it's a bug, is that you see this button here for empty columns. You can toggle it to display a column that is empty, because the natural behavior of GoaT is whenever the column doesn't have anything, it collapses it and it's not displayed anymore. So what was happening to your query is that since I was looking for not the presence, but for our absence, it started cutting out the columns. And this is a bug that we know and we are working on it. So that's why it's a bit harder than, I mean, it looks a bit harder than what it actually is, but we can control everything in the top. So here it is. We have a list of species of the country. Now we want to say, and assembly level equals null or contig. So these are all, okay, 8,000, it's less. A list of species that don't have sequencing, or if they do, they only have at the contig level. And then, and sequencing, status equals null. So nobody's working on them. That's the list, 6,000. If you want to restrict even more, you can put and other priority equals null. So nobody's prioritizing that species. Okay, and voila, this is your initial list. Does that make sense?
Yeah.
Yeah. So then from it, you can actually, so if you go to the bottom and you extract a TSV, you can actually delete all of these and get only the, let's say, columns. You don't need to get any information of chromosome number. Actually, you could if you want to have it as your own starting list and just copy and paste it in a Excel spreadsheet. But let's say you want the ranks. Usually we ask for family information from GoaT. And update. Oh, some species don't have family. That's interesting because they are called clades in NCBI taxonomy. So let's not make things weird. They're about family. But what you could do is just get this, get the list of species that you retrieved. Just get the first and the second column and use that as your initial target list for your project.
Okay.
Sorry for the confusion. It's just that because of this button here, things get a bit more complex to display.
Thank you very much.
Thank you. Okay, at least we went over a real use case thing. I have more slides, but I guess I'd rather use like how we did for a real case scenario than just going with things that people might not want to see. So here you will be able to find how to download the data, but I already showed it to you, how to generate the QR code. And then what I can do tomorrow is focus on the side that I didn't show. So tomorrow there will be another session. It's not going to be at the same time, but I can kind of do a recap of what we saw today and then make the session like a frequently asked questions part 2. Because then it's saved on BGA as a follow-up to this one. And then we have how to use UI, how to do project queries, and then now next step is going to be the more other problems and real life things. How does that look, Damon? Because since it's going to be recorded anyways, people can see all. All right.
It means I can stick it as its own YouTube playlist as well.
Awesome. So I'll just put I'll put it on the what's the name? My slides. The place where I stopped here, exercise 4. And then tomorrow we keep going from here, and I'll just adjust the presentation so it makes sense. All right, thank you everybody that came for the talk. Sorry about the confusion with the schedule. I hope to see you tomorrow as well, or catch up on YouTube. Thank you.
Thank you very much.
Thank you. And
Bye.
actually contact me separately because then I can help you with your list.
Awesome. Thank you.
Awesome. See you.
Bye.
Ciao, ciao. Have a good
See
night.
you all tomorrow.
Bye.